Hi everybody. This video we're talking about all sorts of odds and ends. Well, mostly odds. See, this time the topic is probability. The chances of something happening, usually expressed as either a fraction or a percentage, which hopefully we remember already is just a fraction out of 100 anyway. Either way, this fraction is made up of two things. The numerator, top number, is how often you get one specific outcome. The denominator, bottom number, is the number of all of the possible outcomes. A simple example of this is a coin or a die. On a fair coin, you can flip heads or tails, and both are equally likely. Two outcomes, so our denominator is 2. And if I'm looking for heads, that's 1 out of 2 outcomes, so I have a 1 in 2 probability, 1/2 or 50% chance. On a fair die, a 6-sided one anyway, I have 6 faces that I can roll, so my denominator's 6. If I want to roll a 5, that's 1 out of 6 outcomes, so I can say I have a 1/6 chance. Rounding, that's about 17%, but you know. I could also be looking for something else though. I have 3 numbers on a die, or 3 even numbers on a die, so I have 3 of my possible outcomes that are even. My chances of rolling an even number on a die are 3/6, 50%. That's about it for the basics. But you know I have more to say. I always do. Okay, now probability is actually really funny in terms of how people understand it, because it's both very simple to understand, but also one of the things that people have the worst instincts for in the real world. One of my favorite stories about all this goes back to what was the most popular game in the world around 2010, World of Warcraft. World of Warcraft. Now, when Blizzard, the company that now makes Overwatch, was making this RPG, they originally used realistic probability. That means that if killing a certain enemy had a 1% chance of dropping a really good weapon, it had a 1% chance of dropping that weapon every single time you killed that enemy. And playtesters hated this. Now to most people, if you say a 1% chance, you think 1 in 100. Which, in their minds, means that if you do something 100 times, you should definitely get this item or weapon. Unfortunately, that's not how probability actually works. See, if you have a 1 in 100 chance the first time, the universe doesn't check off some invisible tracking sheet somewhere and change your odds to 1 in 99 for the second, 1 in 98 for the third, until eventually, by your 100th try, you have a guarantee, a 1 in 1. See, if it's 1%, it's 1% every time. Your odds don't get better on trying it again and again. That makes for a terrible game, though. And what Blizzard eventually did was change the programming of the game to do exactly what I just described. Every time you failed, the game would tweak your odds a little bit, make them a little bit better for the next try, until eventually, on your 100th try, you were guaranteed to get that item. Item get! Now this is incredibly unrealistic, but it makes for a much more fun game. More importantly, and strangely, playtesters now said this feels right. They were happy. Now what feels right for probability is often actually wrong. It's why casinos are able to take advantage of people. If you play what feels right, you're probably going to end up losing a lot of money to them. Now what probability feeling right comes down to a lot of the time can be the difference between 2 different kinds of probability. We call them experimental probability and theoretical probability. And usually when we talk about probability, we're talking about theoretical. It's that feeling that, oh, if it's a 1%, 1 in 100, I should get it. But that's not always how things play out. And let's talk about why that might be. Theoretical probability is what we know our odds to be in a vacuum. Absent of the rest of the world existing, we don't need any data at all to know this. I've got my D&D bag here. Let's take a random die out of it. Now, I'm going to pull this. Now, I'm an RPG nerd, as you probably could tell from the Warcraft talk, And this is what we call, if you're a D&D player, a D12. It's a 12-sided die. A dodecahedron, if you will. Now, I know this is a fair die, so every outcome on this die is equally likely to happen. Since this die has 12 sides, I know I have a 1 in 12 chance of rolling a 1, a 1 in 12 chance of rolling a 2, all the way to 12. That's the theoretical probability. It's what I should get, in theory, if I roll this die 12 times. Each outcome has a 1 in 12 chance, so I should get each outcome once. In the real world, this doesn't always happen. What I should get and what I do get are not the same. If you've ever played a game like XCOM and lost a mission over a shot that had 80% odds of hitting, you know what I mean, and you know that pain. This is where we come down to experimental probability. Now, experimental probability is the results you actually get when you conduct an experiment and record your results. Let's actually roll this die 12 times and see what I get. Here are my results. I got a 1 once, no 2s, 3 each for 3s and 4s, no 5s, no 6s, 1 7, 1 8, 1 9, 1 10, 1 11, and no 12s. That's not what I should have got. I have 2 too many for my 3 and 4, and those should have gone to 2, 5, 6, and 12. That would be exactly what I should get in theory. In theory, each outcome on this die is equally likely. This didn't happen. The thing is, the more times I roll that die, the closer the numbers should get to all being equal across all 12 outcomes. If I keep rolling this die for infinity, the longer I went, the more likely it is that all 12 outcomes happen the same number of times. The closer we get to infinity, the closer we get to perfect probability. But this is what we call a small sample size. See, the smaller the number of tests we do, the more likely something is going to be off. So if you're only doing a 1% thing 100 times, you're probably not going to get your one outcome. You probably need to do it a couple hundred, and then you'd get a couple over that time. This is one of the reasons that statisticians like to have the largest sample size they can. When you're running experiments, the more times you do something, the more likely the results you're getting are accurate. If you're doing something that involves probability, the more tests you do, the more your experimental results will get closer to what they should be in theory, and give you better information than if you only did something a couple of times. If I rolled this die 4 times and got a 2 each time, I may think that this die is built to only roll 2s. But the more times I roll it, the more likely it is that I'll get 2 just as often as everything else. Theoretical probability tells me everything has an equal chance of happening. Experimental probability tells me that I got a 3 or a 4 both 25% of the time here. That's it for today, grade 5s. Now to recap, in a sentence, and kind of relate it to our grade 5 science, the difference between theoretical and experimental probability is a lot like the difference between climate and weather. One's what you expect, the other's what you get. Sometimes these match. Hooray! And the more data you have, the more likely you are to bring the two to meet one another. That's it. Have an improbably awesome day. Peace.